I'm Anil Kumar, and in this video we'll try to relate coordinate points with the sine and cosine values. The question here is, determine the coordinates of a point Pxy resulting from a rotation of 75 degrees centered at origin and starting from point 5, 0. So let me draw the coordinate plane here and then we'll try to understand the situation. So what we have here is that there's a point xy which has undergone the rotation of 75 degrees centered to origin. That means centered to origin and starting from position 5, 0. So let us say that is the starting point and this position is 5, 0 for the point. And now it rotates through the angle of 75 degrees, right? So this is 90 degrees. So it is kind of rotating. So the arm length here is 5 units. Do you see that? Now it rotates kind of like this. So once it rotates, and let's say this is 75 degrees for us, then it gets to a position which is kind of like this, let us say, right? Now where the angle at the center measured counterclockwise, it's 75 degrees. So that is the position, right? Now let's read the question once again. It says, determine the coordinates of point P. So this is the point P, which is xy, resulting from a rotation of 75 degrees centered at origin, starting from point 50. So starting from point 50, when you make a rotation counterclockwise 75 degrees, you land up at P. Now you need to find the value of x and y. That is the question. So I'd like you to pause the video and try to solve this question. Now here, to solve this question, what we will do is, we will drop a perpendicular from point P to the x-axis. Now if I do that, then this distance here represents x, correct? And this distance here represents y. But we know one thing, that the hypotenuse, or from O to P, the distance is 5 units, right? Since the starting point was 50 and we have just moved counterclockwise from there, right? In this direction. So the radius remains constant, right? So using primary trigonometric ratios, we can find x and y. You know what is sine of 75 degrees in this case? Sine of 75 degrees will be opposite side over hypotenuse. Here you can see opposite side is y and hypotenuse is 5. So from here we can rearrange, cross multiply and find y. So we get y equals to 5 times sine of 75 degrees, correct? Similarly, we can also find the value of x by using cosine ratio. So cos of 75 degrees, as you know, is adjacent over hypotenuse, right? So that is, adjacent side is x over 5, the radius, right? So from here we can find x is equals to 5 times cos of 75 degrees, correct? So basically we have x as equals to, in general, r cos theta, whatever the angle theta be, and y is equals to r of sine theta in general. And we have a particular name for it. We call it polar coordinates. Anyway, for this particular situation where the angle theta is 75, let us find out the value. So what is y? 5 times sine of 75. So we will do 5 times sine of 75 equals to minus, how could it be minus? Let's do it again. Oh, I see. My calculator is in radians. So let me convert it into degrees first, right? So shift mode and degrees is 3. Okay, now let's do it. So it is 5 times sine of 75 equals to, let's convert to decimals, 4.8296. So we can write this as y equals to 4.83 approximately. Okay. As far as x is concerned, it is going to be 5 times cos of 75 degrees, which is in decimals 1.294. So let me write this as 1.29 approximately, right? So these are the x and y values, and therefore we can say that the answer is point P is indeed, we'll say exact value is 5 cos of 75 degrees or 5 sine of 75 degrees, and what we calculated it was for x 1.29 and for y it is 4.83. You get the idea. So that is how you can find the coordinates of a point after rotation, right? I hope that is absolutely clear and helpful. Thank you and all the best.